Students, can you all hear me? Can you hear me? Right. Right. Good evening, all of you. Good evening, Pranali. So today we have to start organic chemistry reaction practice. So session number 9, I guess. Okay. So today we are starting from the carbon increase in reactions number 10. Okay. So without wasting time, let's quickly go for the reactions that we have to discuss. Right. Carbon increase in reactions number 10. So what I'm going to discuss here is actually Friedel-Crafts alkylation. Friedel-Crafts alkylation. Because in the Friedel-Crafts alkylation, what will happen is we are going to discuss about alkyl groups are connecting to the benzene ring. Okay. So we discuss about the Friedel-Crafts acylation. So this is Friedel-Crafts alkylation. Actually, we have discussed this one under the theories also. So you have to understand that the benzene, right? For an example, let me consider here. We have the benzene molecule and we are adding alkyl halide like CH3Cl in the presence of a catalyst like anhydrous aluminum trichloride. Okay. So then what will happen is this hydrogen is eliminating from the benzene ring along with the chlorine atom in the alkyl halide. Then CH3 is coming instead of that hydrogen, then it is producing methyl benzene or else toluene. And we can say that the byproduct of the reaction is HCl. Okay? So we have already discussed this one under the theories. Very easy. So under the Friedel-Crafts alkylation, what will happen is alkyl halides are added to the benzene ring in the presence of anhydrous aluminum trichloride like a catalyst. Then the alkyl group is connected to the benzene ring. Then we have this kind of alkyl benzene. Okay. So we know that this is actually known as toluene. Right. So let's consider a few examples reactions. Another one. So just imagine we have the benzene. We are adding CH3, CH2Cl along with anhydrous aluminum trichloride. So what will happen? It will convert into ethyl benzene CH2CH3. Got it? Second example, quickly write with me. These things are very easy. I'm gonna add chlorobenzene for this one, right? Chlorobenzene along with anhydrous aluminum trichloride, right? What do you think? Are you expecting a result from this? Right? Are you expecting a product like this in this way? What do you think? Are you expecting that kind of a reaction? No, remember, students, there won't be any reaction because we have discussed the reason. Under the alkyl halides, I told you that chlorobenzene and vinyl halides, right? So they have some kind of a strong carbon chlorine bond. There will be a partial double bond character, right? When we draw the chlorobenzene's resonance structures, we know that carbon and chlorine both are having some kind of a partial double bond character. So therefore, it's very difficult to remove chlorine from this benzene, right? We have discussed this on many times, right? In many reactions, we discussed that even in the phenol, when we add PCl5, there won't be any reaction. For the chlorobenzene, we are adding alcohol, aqueous KOH. Then chlorine cannot be removed. So therefore, there won't be any reaction by the addition of this compound, right? Try to understand. So third example, let me consider in this way. CH3, we are adding a compound like CH3, CH3, Br in the presence of anhydrous aluminum trichloride. Okay. So what are the products that you can obtain? Just imagine here we have CH3 group already. Now we are adding this alkyl halide in the presence of catalyst, not directly for the benzene. We have methyl benzene, right? Students, tell me, methyl benzene, methyl group, is it orthopara directing group or meta directing? It is exactly a orthopara directing group. It is an orthopara directing. So since it is an orthopara directing group, we know that this alkyl group should be connected to the ortho and para positions. So you will have two compounds, two possibilities in this way, CH3, and we can say that carbon is connecting here in this way. So this is that ortho product, right? This alkyl group can be connected to the ortho portion of the benzene as well as para portion. Para portion is also activated. CH3, we can say that CH3CH and CH3 here in this way. So this is the third one. Quickly come to this one. Example number 4. Just imagine we have this kind of a ketone, benzene, C double bond O CH3, a ketone like this. And we are adding here compound like CH3Cl, anhydrous aluminium trichloride. Then what will happen? So this is actually, this is meta directing group. So therefore CH3 group should be connected to the meta position of the benzene, CH3. Number 5. We have benzoic acid. Number 5, just imagine we have benzoic acid. For the benzoic acid, we are adding ethyl chloride in the presence of the catalyst. And then we can say that it's producing carboxylic group. Carbon is containing a double bond, right? So therefore, definitely, alkyl group should be connected to the meta position CH3 in this way. Okay, like this. Number 5. Quickly complete the reactions. Now, here I'm going to discuss some special 2 reactions. You have to understand these 2 also. Put 2-3 star marks on this one using the red color pen. This is very special. No? Students, now just imagine we have the benzene ring. I'm going to add here propyl chloride. CH3, CH2, CH2Cl, anhydrous aluminium trichloride. Okay. Do you know that? Here actually we have 2 products. One is major product and the minor product. We are expecting the result like this, propyl benzene. But remember, students, this is the minor product of the reaction. Right? This is the minor product of the reaction. Do you know what is the major product of this one? Major product is, we can say that CH3 in this way. Right? Can anyone tell me, even though that we expect this one as the major product, why we obtain this one as the minor product and we have another product? So this is the major product. Why we obtain this kind of a major product? Can anyone tell me the reason simply? I need the simple reason. Right? 2 words are enough to tell me the reason. What is the reason for having this kind of a major product and the expected result is the minor product? Can anyone tell me the reason behind that? You know it. You have learned that. Yes, Opeshani, correct. Very good. That is the answer. Answer is stability of the carbocation. Remember that now we know that after removal of chlorine, what is the carbocation we have? CH3, CH2, CH2 plus. This is the carbocation. So we can say that CH3, CH2 group is connected here, 2 hydrogens, and so carbon is positively charged. So this is the carbocation. Now this carbocation is rearranging, students. This is rearranging. How it is going to rearrange? What will happen is this CH3 group is coming towards this carbon atom by exchanging this CH3 and hydrogen. That means this can be converted into CH3 hydrogen CH3 in this way. Look at this one. A primary carbocation is converted into a secondary carbocation in order to obtain the greater stability. So you have learned about the stability of the carbocations. So when we discuss about the stability of the carbocations, tertiary carbocations are the most stable carbocations. Anyhow, this primary carbocation in ethyl group CH3 can be converted into, this can be shifted and hydrogen is connecting here. Then what will happen? It is producing this kind of a secondary carbocation. And now this secondary carbocation is connected to the benzene ring in this way. Then that will be the major product. And this is the minor product. So the stability of carbocation matters here a lot. So that's why we have this kind of a product. Okay. So therefore put 2-3 star marks on this conversion. And this will be very important. Sometimes in the exam, they might ask these things, especially in MCQs. Right. If you consider this is the major product of the reaction, that is wrong. Huh? Not possible. I'll discuss another one like this. Another example, number 7. Look at this one. Number 7, we have benzene ring in this way. We are adding alkyl halide like CH3, CH2Cl, anhydrous aluminum trichloride in this. Then what should be the product of this reaction? Right. So here also we have both major product and minor product. We have a major product as well as a minor product. So how we can go for the answer in this kind of way? Again, remember, look at this one. After removal of this chlorine atom, so does the carbocation that we have obtained is CH2 plus. So this is a primary carbocation. So this primary carbocation can be converted into a tertiary carbocation. How? This hydrogen can be shifted here, and then this positive charge is going there, and then we have CH3, and here also methyl group is there. This is positively charged. Then you can see that there are 3 alkyl groups. So this is a tertiary carbocation. Then this is the major product. Then what will happen? Benzene is connected to this kind of a tertiary carbocation, CH3. Right? Then what is the minor product? So the minor product is the one we expect. The same primary carbocation is connecting to the benzene ring. So that is the minor. Then we can say that here CH2, CH3. Can you understand? Or else we can simplify this one as CH2. Yes. Minor product and this is the major product of the reaction. Right? Okay. So please note down these things. This is also very important. So please put 2, 3 star marks on the question number, conversion number 6 and 7, because those two are very, very important. Okay. Stability of the carbocation matters here more than the product. Try to understand. If you have any doubts, put your doubts in the chat box. Right, okay, are we done? Right. Now, so before we go for the conversions related to this reaction, let's move to the special conversion reactions. Okay. So the next reaction, special conversion reaction. Number 12. Special conversion reaction number 12. So the reaction is reaction of primary amines with nitrous acid HNO2 nitrous acid. But remember, nitrous acid is unstable, so therefore we are adding here sodium nitrite and diluted HCl both together to produce nitrous acid. Because students, when we add sodium nitrite along with HCl, what will happen? You can see that sodium nitrite and HCl producing sodium chloride and HNO2, nitrous acid. So this is nitrous acid, right? So that's why we are adding these two. Even in the conversions, without adding HNO2 directly, put their sodium nitrite along with diluted HCl. The reason behind that one is HNO2 is unstable acid. It is an unstable acid. So let's see what is the reaction here. Primary amines means definitely there will be NH2 group. Okay. So primary amines are reacting with nitrous acid. Let's see. Let's see what kind of a reaction is that. Look at this one. We have a primary amine. This is ethylamine. We are adding sodium nitrite along with diluted HCl. What is the product? So this is the reaction we can convert primary amines into alcohols. That means NH2 group is converted into what? OH. NH2 group converted into OH. Remember, here we have a byproduct like nitrogen gas. N2 gas is the byproduct. Let me consider another example like this. CH3, CH, CH3NH2. Primary amine. We are adding sodium nitrite along with diluted HCl. It is producing OH plus. The nitrogen gas is, as you can see here, NH2 group converted into OH. Right? Number 3. A primary amine, sodium nitrite and diluted HCl is added. Sometimes in the exam, they might give HNO2. Okay. If they have given HNO2, yeah, nothing to worry. You can use that one. Instead of the sodium nitrate diluted HCl, if they have given HNO2, then you can use that. Right? Sometimes they are doing those kind of things, right? CH3. So here also, you can see that NH2. So what about aniline? You know that aniline means NH2 group which is connected to the benzene ring. So that is also primary amine, right? So we are adding sodium nitrite and HCl. So what do you think? Yes. Here we have a product like phenol, OH. Right? Yes. You expected that there is no reaction, right? But remember, Pranali, yes, that is actually yeah. But NH2 is actually, we know that there is a benzene ring activating group, right? Can you remember in the activating group list, I gave you this is the highest one, NH2 group. So it can activate the benzene group. So therefore, it doesn't matter OH group can be converted into this compound in the presence of an acid. And remember, the next thing is NH2 has some kind of a basic nature because nitrogen has a lone pair. So there is a small basic nature on nitrogen. So therefore, it can react with this kind of acid and produce this. Right? So here nitrogen gas is liberated. So these are the example reactions for the primary amines with nitrous acid, sodium nitrite, and diluted HCl. I want to discuss this reaction further, the fourth one with you again. First of all, come up to here, note down these reactions. Right, okay. Now, students, I told you that I want to discuss the fourth reaction with you. Now listen to this one carefully. Actually, now according to this reaction, I have given you that aniline is converting into phenol, right? So what exactly happened here is, so write down a subtopic like in this way. This is known as diazotization. Diazotization, right? Maybe the name is not familiar to you, but the compound diazonium salt, you have heard of it, right? Maybe the term is strange to you, diazotization. Diazotization means the process of producing diazoniums. So, actually, this aniline, primary amine, this is converted into not only primary amine. Let's start from the alkylamine like this, RNH2. When we add sodium nitrite diluted HCl, what will happen first? Remember, students, this is converted into diazonium salts. This is alkyl diazonium salt, right? Understood? This is what happened. At next, this is converted into what? Alcohol, ROH. So the byproducts are N2N, HCl in this. So when we have aniline, in the case of aniline, here what will happen? Sodium nitrite and diluted HCl is added. Then it is producing aryl diazonium salt. Cl minus, nitrogen is plus. So when we add water, what will happen? This is converted into phenol. Nitrogen gas liberated, HCl is. Actually, this is the reaction. I didn't mention these two intermediates. But we know that the final product, we need the final product. In a reaction, what we need is final product. Reactant, a chemical region is added to that one. And what is the final product? We don't worry about the intermediate. But we have to discuss this intermediate also here. Because this is actually well-known one, diazonium salts. So then don't we have any method to stop this reaction at the diazonium salt stage without going for the alcohol? Yeah, in conversions, we can do that one. Right? In conversions, what about if we want to convert this aniline into aryl diazonium salt without going for the phenol? The next step that we want is this one. Then there is another reaction that you have to learn. That is what known as diazotization. In that reaction, what we do here is, look at this one. Let me consider this reaction. We can stop this reaction in the diazonium salt stage by maintaining the temperature from 0 to 5 degrees Celsius. 0 to 5 degrees Celsius. Then we can stop this reaction at here. Can you understand? Actually, this is very famous in conversions. So this is actually alkyl diazonium salt. This is aryl diazonium salt. So we can stop this one, this reaction at the diazonium salt stage by maintaining the temperature from 0 to 5 degrees Celsius. Same nitrous as it is. Okay. So this will be very, very important in the conversions. That's what I told. That's why I told this one. Got it? Same thing here, right? If you want to stop this one here, 0 to 5. This is kind of addition PCC to the primary alcohols, right? primary alcohols. They are oxidizing into carboxylic acids in the presence of strong oxidizing agents like acidic KMnO4, acidic CR2O3, CrO3, acidic dichromate. Directly, they are going for the carboxylic stage. But we can stop that reaction at the aldehyde stage by addition of PCC, pyridinium chloroform. So this is also same kind of a thing. But here we are not adding anything else. We just maintain the temperature from 0 to 5 degrees Celsius. So that is enough to stop the reaction at the disodium salt stage. Okay, right. So quickly, now done this one. Okay, now we can go for some conversions quickly. Students, after the completion of this organic reaction sessions, then I will discuss all the isomers question from 2011 to 2024, right? All the isomers questions from 2011 to 2024 A level will be discussed after the completion of this reaction sessions. Okay. Now actually we are at the end. 2-3 sessions should be discussed here, and then let's directly go for the isomers because we have to discuss isomers. Always isomers are becoming more difficult for the students. That is because of not having enough practice and not understanding the concepts behind the isomers. Okay. Quickly complete this one. Right. Okay. Are we done? Right. So then let's move to the exercise. So quickly complete these questions. Number two. So quickly complete these conversions. Now go for the first one. Here we are adding sodium nitrite diluted HCl. Just now we learned NH2 group is converted into OH. Then here PCl5 is added. And here you can say that this is alkyl halide, then Friedel-Crafts alkylation, benzene and anhydrous aluminium trichloride is added. Then chlorination, chlorine anhydrous. Let me put here ferric chloride, FeCl3. Then here magnesium dry ether is added. Then here we can say that a ketone, an aldehyde, CH3, C double bond H is added. Then H3O plus is added here. First one. Second one. So this is Friedel-Crafts acylation. CH3 C double bond O Cl, anhydrous aluminum trichloride. Then again, Friedel-Crafts alkylation, CH3Cl, anhydrous aluminum trichloride. So this is meta-directing group. That's why CH3 is connected. And here we can say that CH3, MgCl, Grignard region is added. H3O plus here. Then here we are going to add conc H2SO4 and heat this one. So here, what is the product? Bromine is added to the carbon atom where that hydrogen is connected more. That means this is not the Markovnikov, this is anti-Markovnikov. Then HBr is added in the peroxide medium, ROR. And Br converted into OH means this is aqueous KOH. Aqueous KOH. So this is the second one. Right, okay. Shall we move to the third one? Number 3. Starting from ethylamine, sodium nitrite, diluted HCl, added, PCC added here, diluted sodium hydroxide is added, H plus and heat, Br2 is added, alcoholic KOH, HCN is added, then PCl5. So let's move to the fourth one. Benzene, chlorine anhydrous ferric chloride, magnesium dryether, ethanol is added, H3O plus, concentrated sulfuric, heat, Br2, alcoholic KOH. CH3 MgCl Grignard region. D plus D2 is added. Go for the answers. Let's see. So in here, CH3, CH2, OH. Primary alcohol, right? We adding PCC means it converted into this kind of an aldehyde. So diluted sodium hydroxide is added. And after that, H plus heat. Plus, you know this reaction, aldol condensation, right? So therefore, CH3, OH and H here. So this is the alpha carbon atom. From the alpha carbon, hydrogen is removed. So therefore, CH2, C double bond OH. So H plus and heat means OH is removed from hydrogen. So then the compound is CH3, CH double bond, C double bond H. Then Br2 is added. Then the product is CH3CH, Br, C double bond H. Alcoholic KOH is added, therefore, two bromine atoms are eliminated with hydrogens. And in this. So HCN is added, therefore, is converted into OH. So PCl5 is added, therefore CH3, C triple bond C. Cl. Go for the fourth one, chlorination. Benzene, chlorine atom is connected here. Magnesium is connected this one, so therefore magnesium chloride. Now this is aldehyde. Grignard region with the aldehyde. CH3COH. So this is OMgCl. Then we have so when we add considered sulfuric and heat, what will happen? This is producing so Br2 is added. CH3MgCl is added. So therefore, in this way. So after addition of D plus and D2O, what is the product? So this is the fourth. Right. So let's do this conversion number 5. Friends, I haven't specified the number of steps here, but the only condition that I'm going to give you, you can't use any organic compounds from outside. This is the only organic compound you have to use. Other chemical reagents can be used. Right? Using this one as the only organic compound, you have to do this conversion. How we can do this? Let's see how many of you can do this conversion. Quickly do this conversion. You can't use any organic compounds from outside. This is the only starting organic compounds. You have to obtain this one. So when you look at this organic molecule, you should be able to understand this is a product from aldol condensation, right? Alpha, beta, unsaturated aldehyde. So therefore, definitely the previous few steps are actually aldol condensation. Quickly do this one. Raise your hand those who completed this conversion quickly. Anyone here? Raise your hand those who completed this conversion. Why is this difficult? Hmm? Right, okay. I'll discuss this one. Now look at this one very carefully. So they have given a primary amine. So we can start from addition of sodium nitrite in the presence of diluted HCl. That means nitrous acid. Then it is converted into CH3CH, OH, CH3. Secondary alcohol. Okay. Then students, I'm going to add acidic KMnO4. Then it is producing CH3, C double bond of CH3. So this kind of a ketone. For this, I'm going to add concentrated sulfuric CONH2SO4 and heat. Then it is producing CH3, CH double bond CH2. Then here I can add HBr in the peroxide medium. Then the product is CH3, CH2, CH2b. Antivalproic of fluid. Then here I can add alcoholic KOH, aqueous KOH. If we add alcoholic KOH, what will happen? Elimination. So therefore we have CH3, CH2, CH2OH. Okay, aqueous KOH. For this, I can add PCC. Then I have CH3, CH2, C double bond H. Propanol. Propanol, right? Then, now, we can consider the reaction between acetone and the propanol. Acetone and the propanol. Okay. Then it is producing. So this is what? Condensation reaction. But this is a condensation reaction from two different compounds. Acetone, that means 2-propanone, and this is propanol. Right? So therefore, according to the products, final product that we have obtained, we can say that we can put this CH3 bond down. And here we have OH. So this is the alpha carbon. I'm going to remove hydrogen from there. Then CH3, C double bond OH. Okay. So this is what? Aqueous sodium hydroxide, diluted aqueous sodium hydroxide. Then you know what to do. OH and H can be removed by addition of concentrated sulfuric again. No, we can do that H plus and heat. Ne? So we can reduce the number of steps by adding number 1 for sodium hydroxide aqueous and H plus heat is the second. Then directly you can go for this one. So this is the conversion that they have explained. Okay. So I didn't use any organic compound from outside. Now I can easily convert this one into 1, 2, 3, 4. Within 3 steps, I can do this one. If I have add this propanol compound as an outside compound for inorganic compound. But we have to produce this propanol compound in the reaction in the given compound from itself. Sometimes they are giving that kind of conversions. You have to use the given organic compound only. We can't use any other organic compounds from outside. Can you understand? So this is the way that we can do the conversion. Right. Raise your hand, those who understood that conversion. Quickly. Do you have any doubts there? At least did you came to the closer? ළඟට හරි ආවද? පොඩ්ඩක් හරි ළඟට හරි? Yes, sir, I came to the closer. I didn't. I couldn't manage that. Right. So this is the number 5, conversion number 5 in this exercise. So we have another one. Quickly come to this one. So the next one is number 6. Conversion number 6. Ethylamine CH3 CH2 NH2 converted to this kind of a amide. Right? So as before, we can't use any other foreign compounds. This is the only compound. Okay, I'll discuss this conversion with you. Look at this. Here I'm going to add sodium nitrite diluted HCl. Then it is producing CH3, CH2, OH. PCl5 is added, so therefore CH3, CH2Cl. Here I'm going to add acidic came NO4. Then carboxylic acid is added. Again, PCl5 is added. CH3, C double bond. For this, I'm going to add excess this compound again. The initial one, CH3, CH2, NH2. And then we can see that CH3, CH2. This compound is. Yeah, this is formed. Hydrogen is eliminated from there. So when you add this compound together, okay, that's all. That is the conversion. No? Quickly complete this one. Right, okay. Are we done, students? Shall we move to the next one? Okay. Now let's move to the next reaction type. Carbon increase in reactions number 11. Carbon increase in reactions number 11. Okay. Reaction of Grignard, reaction of esters with Grignard region. Reactions of esters with Grignard region. Yes. With Grignard region. Let's see. Let's see how this reaction is proceeding. Since we have discussed about the reaction between Grignard region and aldehyde ketone, right? Now this is the reaction between esters and Grignard region. So let me consider an ester like R, C double bond O. Here again we have another alkyl group R. Just imagine you are going to add here a Grignard region like R dash MgX. So the specialty of this reaction is, remember students, when Grignard region is reacting with esters, so that is special. Do you know why? This R dash alkyl group is connecting two times for the carbon atom. It is connecting to this carbon atom two times. First of all, this is breaking. Breaking, and R dash group is connecting to that carbon atom two times in this way. R, C, R dash, R dash. And MgX is connecting to that oxygen there. OMgX. OMgX. Right. Then we know that when we do the hydrolysis reaction, when we add H3O plus, what will happen? Hydrogen and OH is connecting here. Then it is producing RCOH. Here we can see R dash. Can you understand? Remember, students, actually, why these two alkyl groups are connecting in this way? The reason is these esters are, first of all, converted into, not directly for the this kind of alcohol. What will happen is this is converted into a ketone like this, RC double bond R dash. Okay. And then further, it react with this Grignard region. Then only another alkyl group came from the Grignard region is connected here and converted into this kind of OMgX. Then after addition of H3O plus, we know that this is converted into this kind of a alcohol. Can you understand? So this is what happened. This is why two alkyl groups are connected to the ester compound. Right? That is what happened. So let's consider a few example reactions. Example number 1. We are adding CH3 MgCl, secondly H3O plus. So what is the product? Break this one from here, CH3 OH. Then alkyl group which is coming with the Grignard region is connecting to that carbon atom two times. That's two times. Number 2. CH3 CH2 C double bond O CH3. Then we are adding Grignard region like CH3 CH2 MgCl. H3O plus is added secondly. Okay. Then remember, students, this alkyl group is connected to that carbon atom two times. Then this is the product 4. This is the product 4. Quickly come to this one. Example number 3. Methyl magnesium iodide, H3O plus. So what will happen? HCOH. Methyl group, which is coming from the green out region, is connecting to that compound. Number 4. This is an ester containing a phenyl group. Benzene magnesium bromide in the presence of H3O plus. So therefore, the phenyl group is connecting to that carbon atom 2 times. Then this is triphenyl compound, right? OH in this. Let's write down in this way. Acid halides can also show a similar reaction. Like with esters, Grignard region is reacting with acid halides in the same manner. Okay. CH3, C double bond of Cl. We are adding the Grignard region CH3, CH2MgCl. Secondly, H3O plus. And then what will happen? CH3OH. So the alkyl group which is came from the Grignard region is connecting to the compound 2 times. In this way. You understand? Right. So this is the reaction you have to quickly go up to this one. Right. Now let's move to the next reaction type. Special conversion reaction. Special conversion reactions number 13. Special conversion reactions number 13. Reduction of aldehydes and ketones. Reduction of aldehydes and ketones. Now look at this one. Students, we have an aldehyde or ketone like this. H, here R. When it is hydrogen, we can say that is an aldehyde. If it is R group, we can say that is a ketone. So we are adding lithium aluminium hydride, and here H3O plus. So what will happen is carbon is positively charged delta plus, carbon oxygen is negatively charged delta minus. Remember, students, this lithium aluminium hydride is giving H minus hydride for this carbon atom. H3O plus is giving H plus to this oxygen atom. Then what is the product? What is the product produced? We can say that is an alcohol. H here, OH. Okay. So the reduction of aldehyde and ketone actually two types. This is a simple A, write down simple A. This is reduction of aldehyde and ketones using lithium aluminium hydride. Simple A, using lithium aluminium hydride or sodium borohydride. Okay. This compound is known as lithium aluminium hydride, which is made by lithium plus cation and aluminium hydride anion, AlH4 minus, lithium aluminium hydride. And this compound is made by sodium plus cation and borohydride, BH4 minus, lithium aluminium hydride and sodium borohydride. Okay. So that is the first method of reducing this aldehyde and ketones. Right. And then example number 1. Let's discuss few examples on this. This is producing CH3OH, methanol. Number 1. Number 2, just imagine we have an aldehyde like ethanol. Remember, students, we can use sodium borohydride also. Sodium borohydride is reacting with methanol. Sodium borohydride is reacting with methanol, then it is producing CH3, CH2OH. Number 3. Here we don't have to put 1 and 2, just put sodium borohydride and ethanol. So here lithium aluminium hydride, H3O plus producing. So C double bond or group converted into OH and hydrogen here, CH3. Right. So ultimately you can understand that here C double bond or group converted into CHOH group. Okay. That's what happened. Number 4. Benzaldehyde. Let me add here sodium borohydride with methanol producing CH2H. So what happens to removed OR? I think you're asking in the ester reaction, right? So Pranali, there you can see that in that reaction finally H plus H3O is added, right? That means the medium is acidic. So can't that OR group connected to hydrogen and from another alcohol? Can they? So that OR group can be formed, can be converted into an alcohol in the medium because the medium is acidic, right? No, 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 no. We can't do that. We can't change like that. Lithium aluminum hydride should be added with H3O plus for sure. Sodium borohydride definitely should be added with. Okay, so that is the those are the regions. We can't switch them. Okay, that means lithium aluminum hydride methanol is not possible. And one more thing you have to remember that lithium aluminum hydride is the strongest reducing agent compared to sodium borohydride. Okay, so when it comes to the reduction of carboxylic acids, I will teach you. Sodium borohydride cannot be used to reduce carboxylic acids. Only lithium aluminum hydride can be used there. Only lithium aluminum hydride is powerful enough to reduce carboxylic acids. So therefore, sodium borohydride than sodium borohydride, lithium aluminum hydride is somewhat strong reducing agent. So let's write down another two examples. Number 5. In this way. So this is the first type of reduction, first way of reducing aldehyde and ketone. Okay, we discussed this one under the oxygen containing organic compounds. We discuss aldehyde and ketones there. And the next thing is what? Simple B. Next type. Clemmensen reduction. Clemmensen reduction. Okay. Clemmensen reduction. In the Clemmensen reduction, what will happen is, just imagine we have this kind of an aldehyde, C double bond O. So the reagent that we are adding is zinc, mercury, concate Cl. Zinc, mercury, concate Cl. Okay. Then what will happen is this C double bond O group is converted directly into CH2. Okay. That means it is converted into an alkane. Right? Aldehyde ketone in the Clemmensen reduction, aldehyde O ketone converted to an alkane. Okay. So that's what happened in the Clemmensen reduction. So here, byproduct is water. Water is a byproduct. Example, we have methanol, zinc, mercury, conch HCl is added, producing CH4. Number two, in this way. So that C double bond O group is converted into CH2. Right. So let's discuss some reactions. Few more examples. Number three, third example, we have acetone. Zinc, mercury, conch HCl. Then it is producing CH3, CH2, CH3. Number four, benzaldehyde, zinc, mercury, conch HCl. This way. So you have to understand that finally what happened in the Clemmensen reduction, zinc mercury concat Cl, that carbonyl group C double bond O converted into CH2. So that's what happened. Okay. Right. Okay. Now, students, let's go for another exercise. Number one, an ester like this. In this way. Alcohol is converted into carboxylic acid. Number two. So the first one, this is actually a Greenart region. Ester reaction. So therefore we can put CH3 MgBr. Then H3 plus here. Kong sulfuric is added and heated. Then HBr in the peroxide medium, right? Aqueous KOH. Acidic KMNO4 is added. PCl5. And here this is Feedercraft acylation. Benzene anhydrous aluminum trichloride. This is actually reduction. Let me put lithium aluminum hydride, secondly H3O+. Go to the second one. Friedel-Crafts acylation. CH3C double bond O, anhydrous aluminum trichloride. Then this is alkylation, CH3CH2Cl, anhydrous aluminum trichloride. So let me put here this time sodium borohydride and Conc H2SO4. HBr in the peroxide medium. Aqueous KOH. PCC. Okay. Is the second one. Quickly complete these conversions. So let's move to the third one. Is the third one. So let's move to the fourth one as well. Here diluted sodium hydroxide with ethanol. Then H plus heat. Lithium aluminum hydride, secondly H3O plus. PCl5. So here we can say that CH2 OH, because aqueous KOH, right? Cl is converted into OH. By the addition of acidic KMnO4, it is converted into carboxylic. PCl5 is added, that means this compound. A Grignard region for this compound. So this is actually same as the Grignard region and ester reaction. That methyl group in the Grignard region should be connected to that carbon atom 2 times. ONGBr here. After that, alcohol is produced. A tertiary alcohol, PCl5 is added. CH2, right? Then sodium derivative of terminal alkyne. Mercury cation along with H3O plus. So therefore, C double bond of CH3. Sodium borohydride with methanol. Here we can say CH3, CH2, CH2, OH. Aldol condensation. Propanol and what is it? Ethanol. So I can say that CH3, CH2, COH. CH2 double bond H. H plus heat. Lithium aluminum hydride. PCl5 is added. So when we add sodium derivative, the answer is CH3, CH2, CH, CH2, C triple bond, because that chlorine is eliminating with sodium plus and this group is connected. So that is the fourth one. Right, okay. Are we done? So do the fourth one and the fifth one as a homework, right? Two small conversions. Soon after the class, you can send me the answers. That's very easy. Number 5. Three steps. Only 3 steps. Okay. Number 6. So this is also just 3 steps. Right, okay. Then do these two conversions as a homework. Let's discuss the remaining conversions in the next class, right? So what are the doubts you have in the things that we discussed today? Do you have any doubts? Now, can you do any conversion that they have given? Are you trying past papers? Pranali, Sarina, Upeshani, Sehanti, are you all trying past papers? Past paper conversions? Yeah. So now you can try, yeah, from 2011 to 2024, try all the organic conversions, right? You do that one, that is very interesting. If you are really interested in organic chemistry, if you are not even interested in organic chemistry, that interest will made by doing this conversion. Will be made by doing this conversion. You try these things, you do. Even if you can't do the isomers questions, by looking at the marking scheme, by looking at the answers, do the questions first time. When you're doing that one first time, it's okay, right? Because you don't have any idea about how the past paper exam questions came before. If you're doing that one first time, right? So therefore, try 2011 to 2024 past exam. Right. Okay, raise your hand. Those who understood the conversions that we discussed today. All clear? Sehanti, Peshani, Pranali, and Sarin. Everyone? Okay, right. Okay. Then let's do the next session in the next week. So this is the session number 9. So we have to quickly finish these things. After that, there are only few reactions remaining. After that, let's go for the isomers past paper discussion 2011 to 2024. Okay. So after April, we can do those things. No issue. The next month we are starting chemical equilibrium. So therefore, it's doing that, right? Okay. Then I'm going to wind up the session for today. So let's meet in the next session. So bye bye. Have fun. Good night for all of you. God bless you.